As soon as I see the word relation, what does that mean I am going to have? Pardon me, Anu? I am going to have what? I just couldn't hear you. I'm not saying if you're right or wrong. You're going to, no, yeah, maybe, if it's continuous data. I'm going to have two sets of data, right? Those two sets of data will constitute a domain and a range. One of those will be what kind of variable? Independent. I will have an IV and a DV. As soon as I see the word relation, I must have two sets of data because a relation compares two sets of data. So, let us read this question. I will allow you to read it silently to yourself. After that, you will tell me what are the two variable values. Don't tell me which is which. Just tell me the two variable things. And what are they? What is one of the things in this relationship that will change? Colin. The cost will change. What is the other thing in this relation that will change? The toppings. Excellent. Now, tell me which is independent. Toppings is independent. Why? Cost depends upon toppings. Now, this is where some wise ass always says cheese is a topping. It isn't. If you do not put cheese on a pizza, you have bread. It is not called Bread Hut. It is called Pizza Hut. Therefore, cheese is not a topping. Even though it indeed goes on the top of a pizza, it is not a topping. Extra cheese is a topping. Because once you have put down the cheese, which is automatically part of the pizza, you put on more cheese. Therefore, it is a topping. But that first layer of cheese is not a topping. Because without it, again, you have bread. So, down here will of course be toppings. Here will, of course, be cost. 1 topping, 2 toppings, 3 toppings, 4 toppings. If you go past 4 toppings, in my opinion, you also do not have a pizza. You have mush. Because once you put on that many toppings, your pizza has no structural integrity, and you have to pick it up with basically a spatula and pour it into your mouth. If you cannot hold the slice of pizza by the corners and have it get to your mouth, then you have too many toppings. In my mind, for my purposes, I only need 4 toppings to teach this lesson, so that is where I will stop. There is, of course, one topping that should not be on that list that is on everybody's list, and that is, of course, pineapple, because pineapple has no place on a pizza. Even though the pizza is called Hawaiian and was invented in Canada, Priya is allowed to like pineapple. There is nothing wrong with that. It is an opinion. I am just saying, since I am running this show, this is toppings, no pineapple. Because that does not count. If you wish for pineapple on your pizza, you go ahead and waste your $1.50. I do not wish to. Now, what is the cost of the pizza? 12. What is the next one? Obviously, it will be $13.50, then $15, then a $16.50. Now, if I put 0 toppings on the pizza, how much does the pizza cost? $12. So open or close dot there. Closed, because if I put no toppings, I am paying $12, yes? Will that cost of pizza change any at all between 0 and 1? No, it will not. Is there any allowable input between 0 and 1 for toppings? No. So where is the next dot going to be? At 1 topping and $13.50. Where is the next dot going to be? 2 toppings, 15. 3 toppings, $16.50. What is the cost of a 4-topping pizza? $18. Why? Don't answer that, because that is the answer to today's lesson. You know that it is 18 because for every increase in 1 topping, you increased $1.50 in cost. $1.50. $1.50. How long will that relationship continue? Not forever. There is not an infinite amount of toppings you can put on a pizza. At some point, the restaurant says, "No, I'm sorry, sir. That is all the toppings we will put on your pizza. You have ordered every single thing on the menu." Which, of course, would be repulsive. But, now let me ask you this. Is this discrete or continuous data? Discrete, because there are no outputs between 12 and 13.50 and no inputs between 0 and 1. But since it maintains a constant rate of change, what is our rate of change? Our rate of change here is always dV over IV, which is 1.5 over 1, which is $1.5 per 1 topping. Since our rate of change is constant, because it is always 1.5 to 1, we have a linear relation. This is what makes this. If the rate of change is constant, you have a linear relation. Notice that it is still a linear relation, even though it's got the word line, and I didn't draw the line. A linear relation need not be continuous. Okay? Okay. Now, the next thing you need to be aware of is linear relations. Linear relations, and I'm so lazy I'm writing that, can be expressed in 4 ways. 1, a sentence. That was at the top of the page, right? Top of page. 2, a graph. That's in the middle of the page. How do you know it's linear? The rate of change is constant, can be discrete or continuous. Now the other 2 are right here. 3 is a table of values. In the 8th, 9th grade, 7th, 8th, 9th grade, you did tables of values. Some of your teachers called them T-charts. I don't know when they got a new name. Probably around the time Puff Daddy became P. Diddy. I'm not entirely sure. Whatever the heck he's called now. What is he now? Just out of curiosity. He's back to P. Diddy? Oh, he's just Diddy now. I see. Okay. Anyways, you know it as X and Y in grade 7, 8, and 9. What did it become in grade 10? IV dV, or input output. Yes? Please notice they are all the same. Now, if we did the relation that we have just graphed, and we used x and y, it would be 0, 12, 1, 13.50, 2, $15. IVDV was toppings cost, same values. Input output, toppings cost, same values. Now, this is what you do if you don't have a graph. I went up by 1, yes? I went up by 150. Now, if that happens once, do you have a linear relation? No, because any 2 points would have a rate of change, yes? It must happen at least twice. Since these are all the same and these are all the same, you know it's a linear relation. Now, this is what bothers me. 3, 16.50. Agreed? Now, what if I put the next number 5, 19.50? Is it still a linear relation? Of course it is, because we went up by 2 and 3. Is dV over IV, 3 over 2, still equal 1.5 over 1? Yes, so it's still linear. Does everyone understand? Spectacular. And the last way you can do it is an equation. In the next unit, I will show you how to get the equation from a graph. That is Unit 6. But for Unit 5, we get our equations from our table of values. And let's look at how that is done, even though I know you all probably know. 0, 12, 1. If I put on one topping, do I still pay $12? Yes, but I have added how much more? 150. Agreed? Everyone understand? If I put on a second topping, do I still pay that $12? Yes, but now I have added how many 150s? 2 150s. Agreed? What if I have a third topping? Do I still pay $12? Yes, plus 3 150s. Agreed? What if I put on T toppings? $12 plus 150 times T. And there is the equation. Does everybody understand? Everybody cool? All right. Linear relations, couple of things to remember. 4 ways to write them. 4 ways to express that's one thing to remember. The simplified rate of change is constant. Because remember, 3 over 2. And remember, a rate of change is always over 1. Right? That's the second thing to remember. And the third thing is it can be discrete or continuous. Is everybody cool to there? Yeah? Everybody's good? Yeah? Okay. Is this relationship linear? Yes or no? Let's check, shall we? How much did I go up by? 5. How much did I go up by? 9. Nice job. How much did I go up by? 5. How much did I go up by? 9. How much did I go up by? 5. How much did I go up by? 9. Is it linear? Yes, this is a linear relation. Because the rate of change is the rate of change is what? It's constant, and it is dv over iv 9/5. Right? All the way along. Agreed? Okay. What about this one? 5, 5. I know it's blue. Is 555 constant? Excellent. Is it the same over here? No. So this is non-linear. What about this one? Yes or no? How could you check? Put in a table of values. Now this is where kids are always like, Mr. Myers, you're a wizard. How did you know what numbers to write here? You don't guess. You say whatever numbers you want there. Why? Because it's the independent variable or the input. How does the computer know what letter to type on the screen? Whatever you push. So what numbers can I put here? Any numbers I want, because it's input. Would it be smart to do 1, 3, and 27? No, why not? So I won't be able to see the pattern. Would it be smart to do 1, 2, 3? Okay, 1, 2, 3. And then, apparently the most complicated thing in all of grade 10 math. X, 1. What letter is that? So what can I write there? 1. That concept is the rest of the year. Do you understand it? Do you? Okay. What is 2 times 1? Plus 4? So what letter goes, or what number goes there? What letter does that 2 represent? What letter is that? X. So what number can I write there? What is 2 times 2? Plus 4? 8. You guys are talking in a very condescending tone of voice. Good, because that's how easy this is. What letter does that 3 represent? What letter is that? What number can I write there? 3. I know people are still saying X when I say what number can I write there. I don't get it. What is 2 times 3? Plus 4. So what do I write there? 10, because Y equals 2 times 3 plus 4. 10. 1, 1. 2, 2. Done. Linear or not? Linear. Nice. What about over here? What should I use? Would it make sense to use negative 27, negative 18, negative 9, and 0? It's a yes or no question. Yes, it would. Why, Henry? Because I'm going up by 9 each time, and it would work, wouldn't it? But it would be a dumb one to use, because how many of you know 27 squared? Exactly. So what would be some better numbers to use? Well, there's a squared there, isn't there? So we should probably throw some negatives in there, yeah? Negative 2, negative 1, 0, 1, 2. I know it's blue. And again, what does the 2 represent? X. What letter is that? So what can I write there? Negative 2. What is negative 2 squared? What is 4 times 4? Minus 1. 15. What's negative 1 squared? 1 times 4 minus 1, 3. What's 0 squared? Times 4 minus 1. Negative 1. I know it's blue. That's okay. It'll all show up in a while. In a while. In a while. Anyways, what comes after? What's the next number? We did negative 2. Oh, are we there? Not quite. What's the next number? 1. What's 1 squared? Times 4. Minus 1. 3. What's 2 squared? 4 times 4. Minus 1. 15. And look at what has happened when the screen shows up. You don't need to because you've made the table of values. What happened? It did not go constantly, did it? When I was at negative 2, I was way up here at 15. When I was at negative 1, I was way down here at 3. When I was at 0, I was at negative 1. And then I went back up to 3, and then I went way back up to 15. It makes a curve. That is what all of grade 11 is based on. A parabola. Is it a line? No, because I went over 1 and up 4. Then I went over another 1 and up 12, right? So it's not linear. What's the only difference between the equations? The exponent. If there's an exponent, it can't be a line. Linear or nonlinear? Linear. Why? Because when I go from there, if I go out 1, I went down about 1.5, yes? So when I go out 1, I go down how far? About 1.5. Linear. What about that one? Linear, of course it is. Why? The rate of change is constant. What's the rate of change? 0. Because I go up 0 over 1. No matter how many times I go over 1, I only go up 0. What about that one? Not linear, of course. Why? It's a curve. What about that one? That one's linear. Make a table of values and graph. Is that going to make a straight line? How do you know? No exponents. So make a table of values and graph. How many points must you have to prove it's linear? At least what? 4? 2? 3. Why 3? You need to have 2 rates of change. Which of these numbers do you get to choose? X. How many? Who chooses the 3 numbers? You do. Would it make sense with the graph I have given you to use 22, 23, and 24? Why not? They're off the graph. Could I use 2, 3, and 4? Yes. What about this one? X, Y, linear or not? No, how do you know? Exponent. The last time we had an exponent, how many X's did I choose? 5, right? So how many X's do you need to choose? 5. What would be a real smart 5x's to use? -2, -1, 0, 1, 2. Why? Because 0 is real easy to work with, 1's real easy to work with, and 2 is real easy to work with. Right? Go, graph those. When you are done graphing those, you get to work on page 201 to wherever the answers start. While you are sketching your graphs, I, of course, will sketch mine because you don't really need to see it now. Why was I able to add all of these dots below 0? Because I know it's a linear relation. Right? Now, do I connect the line? Is this continuous or discrete? It is continuous because can I take any value of x, multiply that by 2, and then add 4? So it would get a line because it is continuous. What about the second one? Do I draw the line? Can I take any value of x? Can I pick any number for x? In number 2, can I square that number? Can I subtract 3 from the result? So is it continuous? Of course it is. Because every value of x will get me a value of y. Is everybody good? Priya, what did you just say? Because I'd really like to repeat it, but I didn't quite hear all of it. And it was actually really important.
Okay, continuous and linear are 2 different things.
Yes. Continuity has nothing to do with linear. Okay? They are separate characteristics. Everybody understand? Okay. If everyone is good, you have 22 minutes to work on page 201. Now listen to me carefully. No, you guys had the lady sub, yes? No, you had Mr. Fisher, bald man. Mr. Fisher marked your cumulatives, but he didn't understand the Unit 4, Unit 3 thing. Do you understand what I'm saying? So I got to go over it. So they will be ready for you tomorrow. All right? You will see changes in Check My Mark tomorrow. Well, you'll see the changes tonight. Now, I have a question of one of you. No, I'll deal with that later. You all are working on page 201. Go. Now, ladies and gentlemen, I know from the fact that I've spent February, March, April, 3.5 months with you, I know that you would rather have your cumulatives marked ASAP so we can go over it and you can get your changes. Which means, since I got a problem right here, I'm going to start doing that right now. I asked 17 times if everybody understood what was going on. Everybody said that they were okay. If you're not okay when you're working on page 201 to whatever, what do you need to do? Before you ask anyone, where should you go? Your notes. 'Cause why? Notes show you how to do the work. What if you're silk and fuzzled? You're like, I didn't take any notes today, Mr. Myers. I just watched. What should you do? Ask whom? The person you are working with. What if the person you are working with cannot help you? Whom then could you ask? Then you come to me, where I will promptly stop everything I am doing and offer you all assistance that you may need.